Well, it is fantastic to be back in London. I was here 3 years ago, and then something happened, and I haven't been back, and so I'm really happy to be here and happy to see all of you, so many friends, and tell you all about MIDI 2.0. Working with some other guys who are going to present more than I will today. My name is Mike Kent. My company is Ominote, and I'm the chair of the MIDI 2 working group in the MIDI Association. Joining me today is of Microsoft. He's joining by video because he couldn't make it here. So, and then we have Phil Burk, Robert Wu from Google, and Torrey Holbrook Walker of Apple. These four people have contributed a lot to MIDI 2.0. Pete Brown is on the executive board of the MIDI Association, and Phil and Torrey have both been on the executive board in the past, and they've all to the environment of MIDI 2.0 a lot. And so thanks to them, they're pretty significant people in what we've done. So I thought I'd just give you a quick status update before turning it over to hear. And so this is what happened to us. We came here 3 years ago to ADC, and we gave a presentation on what is MIDI 2.0 and introduced it to all of you. About half the people in the room, or 2/3, great. And then in February, shortly after that, we actually published the foundational specifications for MIDI 2.0. And then a month after that, thing went south, right? It was just horrible after that. Engineers were all sent home from their companies to do, whatever they could do. Some of them went home and, to be with their family and or other things, right? So there was great distractions to what was going on in the world at the time. A lot of companies were struggling to survive, and the first thing to go is things like R&D. Companies became very risk adverse at that time, and so MIDI 2.0 progress really did slow because of the pandemic, and I think we're kind of about a year behind where we'd like to be. Other bullet point, I don't need to read that out. Many of you have probably been involved in this problem of component shortages and having to redesign products. But here we are, November 2020, back on track. MIDI Association is moving ahead very nicely, and we have a lot going on these days, and moving ahead very quickly. So at this time, we're stage of MIDI 2.0 and doing proof of concept work. A lot of companies are doing internal prototyping, but we're still MIDI 2.0 is something that we're talking to developers about. We're really not trying to promote it to users because we're just not ready as an industry to ship products just yet. But we're moving ahead. A bunch of companies have signed the new logo license, which would indicate intention to develop MIDI 2.0 products. And we expect really the first round of the early adopter products to appear at the NAMM show in April of next year. And probably in the fall, start to ship and some of the underlying architecture that we need, like operating systems and DAWs and libraries, that kind of thing, will start to come out and really make us start moving into the market and switch from the MIDI Association standpoint, the developer focus, to starting to roll it out to users and promote to users. MIDI 2.0 has a lot of features, and so this little piece, you don't need to do all of MIDI 2.0. So as we start out, the first MIDI 2.0 products, may not do everything. I'm sure they won't do everything, but they'll do pieces of MIDI 2.0, and we'll grow together as an industry. In the working groups, we have been focused on prototyping, and that has led us to actually make a few adjustments to the core foundational ideas. Not a lot, but there are a couple of notable ones here. The first one is that protocol negotiation, which you may have seen in MIDI CI, is being deprecated. We found that it fell short of the requirements we had, and so new protocol selection mechanism using new MIDI messages. And there are also new messages that are not located at a group address. MIDI 2.0 has groups of channels, 16 groups with 16 channels for a total of 256 channels. But we also have now a path for kind of a broadcast, bypassing groups and channels. And so there's new messages in there, and those are being used for the protocol selection. These new specifications that reflect some of these changes and a bunch of additional new features. In the next few months, those will be published. We're wrapping up most of them, but there's a few more that we're still working through the final stage of approval, and so those will all be published probably in Q1. The MIDI Association has adopted an open source strategy, and so we have MIDI 2.0 tools, and we're starting to develop some libraries, and we're going to be putting those into open source. Currently, those tools are available to the paid members of the MIDI Association. I encourage you to join a free membership at MIDI.org. There's also a paid membership which gives you access to these tools and many, many other benefits. But in the future, we do intend to release all of these things into full open source for all developers. And so that's a part of our strategy that we're working toward. We have support from a lot of companies, and you'll be hearing from the operating system companies today, and the fact that they're all really involved in the MIDI Association. And about half of the largest DAW companies and some of the smaller ones are members of the MIDI Association, have been participating, and so we see the support. Hardware companies, I know of some that are developing products now, and also we're in discussions with people that are in charge of plug-in formats and discussing now the impact of MIDI 2.0 is for plugins. So we're going to expect, I wrote it down as turbulence landing a plane the size of MIDI 2.0. We expect as new products come up, we're going to be adjusting as we go. As products come out, this guy might implement this feature of MIDI 2.0, and somebody else will implement a different feature, and a user buys them, and they connect, and, well, they don't actually do anything new. They're just doing the same 1.0 did. So it'll take a little while for MIDI 2.0 to become kind of everywhere, and for all users to be able to do a lot with it. It'll take us several years. It's the 40th anniversary of MIDI 1.0. It's hard to believe that a 1.0 can last for 40 years. MIDI 2.0 is a far more extensible approach, and so it's our plan that it lasts for the next 40 years. So the work that we're doing, the work that these OS companies are doing, is a foundation for what we do from here on out. So enough from me on behalf. So next we'll get into the presentations from the three major OS companies that we've invited to this and have agreed to come, or almost all come. Pete Brown of Microsoft could not make it here, and so as a backup, and that's what we're going to look at here today. This is Pete Brown of Microsoft and chairman of the board of the MIDI Association.
Hi, everyone. I'm Pete Brown, lead of the MIDI 2.0 project at Microsoft, and also the chair of the executive board of the MIDI Association. Thanks for giving me the time to speak to you today about some of the cool things that we're doing with MIDI 2.0 at Microsoft. Although I'm pre-recording this session to ensure we don't have bandwidth issues, I'm available online for any questions, and you can also reach me on Twitter or through my email address here, or if it's specific to this MIDI 2.0 project, on our Discord server, which is linked to right here on the slide. You can also find me on Gearspace, because I'm a bit of a gear junkie, honestly, or on Cloudy Nights, because I like to point complicated optics up to the sky and kind of peer back in time. So lots of hobbies there. Today, I'm going to introduce you to the Microsoft Windows MIDI Services, which will be available to developers starting next year. This is a project which has really recently just kicked off, and we're early in development. So everything that I share with you today is to be considered conceptual or preliminary, and it's possible that these things will change over time. Our MIDI 1.0 WinMM API and class driver on Windows has been functional for decades, but it's tied to kernel streaming and to the MIDI 1.0 driver model. This doesn't provide any great user mode extension points. You have to write new drivers for every feature or transport, which makes prototyping new transports or new MIDI ideas much more work than it needs to be. And there are several great third party drivers and tools out there for virtual MIDI, Bluetooth, RTP, and more. A huge thank you to those developers. We natively added Bluetooth MIDI to the WinRT MIDI stack, which is our more modern MIDI API. But that API had some challenges for DAW developers, like requiring asynchronous calls, issues around port naming, a requirement to use strongly typed message classes, and more. Nevertheless, it's a good base to build a modern API on, and it's implemented in several DAWs and in Chromium today. The finalization of the standards for MIDI 2.0, including the USB MIDI 2.0 device class specification, has made it the appropriate time for us to revisit everything about MIDI and develop in a more modern and extensible way. The API, apps, and service are fully open source, officially supported by Microsoft, and permissively licensed so that anybody can port it, learn from it, easily debug with it, and submit pull requests for features or fixes. During our API and service prototyping period, AME member companies approached us and asked about our MIDI 2.0 plans. I explained to them that the USB class driver was still some way away from being developed because the audio teams had a lot of other near-term priorities with the introduction of Windows 11 and the prioritization shifts that COVID lockdown brought along. AME proposed creating a MIDI 2.0 USB driver and donating it to the Windows MIDI Services project as a full MIT licensed open source bit of code to enable others and to unblock their member companies who really needed all the operating systems to support MIDI 2.0 before they could release key products. I thought this was a perfect idea. AME brought in Aminote, experts in MIDI 2.0, to do the USB driver work. Microsoft is collaborating with the driver project to ensure that the driver is up to date to the latest standards. The developers have access to the right tools and testing, and also to manage the repo and provide Microsoft driver signing to the project. Alongside this work, which started in September, we're creating the APIs and tools which will use the USB MIDI driver as the first MIDI 2.0 transport. We've also invited the Linux ALSA developers and other hardware and software companies who are MIDI Association or AME members or under their NDA to the GitHub repo so they can contribute and or learn about the project. Right now, we do have to keep the repo private because we're implementing updated standards that are not yet approved and so are under MIDI Association and AME NDA. Shortly after these updated standards are approved, we can open the repo to the public, but we need to respect the MIDI Association and AME's disclosure agreements and not contribute any confusion to the marketplace by showing unapproved standards. Access to in-progress standards is a really good reason to be a MIDI Association member company if you are creating MIDI products. So we will deliver version 1 of the API in 2023 and previews at key points before then. At the same time, we're working with partners large and small to help them adopt the API in their software and hardware products. The settings and utility apps that we'll deliver with this are most likely always going to be shipped out of band through the Microsoft Store and Windows. This allows us more frequent iteration as well as automatic updates. And we will make it as easy as possible for users and apps to stay up to date and compatible. As much as possible, we will support the latest Windows 10 release as well as Windows 11. But we will not compromise on performance or features or stability of the API here to do this. But we're making smart choices with the intention to support both with this driver, the API, tools, and service for as long as the operating systems are supported. There are so many stakeholders involved in ensuring that we all do the right thing for MIDI 2.0 support for customers and for the developer community. I'm really happy about the collaboration with AME and Aminote and the developer community and what we'll be able to deliver together. So let's talk about some of the specifics. Remember, like I said at the start, although a lot of prototyping was done earlier and over the summer and spring, the project only started in earnest a bit over a month ago. So this is all early information and potentially subject to change. In the current model, The API speaks to the driver stack directly through kernel streaming. In the new model, we have a Windows service, much like we do with audio today, which manages communication between the applications and the transports. This provides us with the ability to make everything support multi-client, which is a huge request and a requirement for MIDI 2.0, and to more easily add in new transport types like the eventual network MIDI 2.0, virtual MIDI, app-to-app MIDI, the existing Bluetooth MIDI 1.0, and more, many of which won't require creating any drivers, just user mode transport plugins. It also enables us to more easily support various types of message routers and message processors, bringing back some of the wanted features from the old MIDI mapper, all using an extensible plugin model. The service also provides a way to transform messages between UMP and byte streams on the back end while keeping the front end UMP centric. This means applications will have the same API to use regardless of the type of messages sent or the endpoints they're connecting to, or the transport being used. The API itself is built on WinRT, which is COM, but with a richer type system that is more easily usable by all different languages. Developers won't need wrapper projects or pinvoke or anything like that to use this API from any of the languages which understand WinRT, like C# or JavaScript or C++ and more. We used to require C++ CX for WinRT access from C++, but that had proprietary extensions to C++ and really kind of didn't go with the way that C++ developers like to code. So the easiest way to consume WinRT types from C++ today is to use C++ WinRT, which is a header-only standards-based interface to WinRT types, which will coexist with your other C++ code. So it's much easier to use those WinRT types today. The existing Win32 MIDI API isn't suitable for the new features, but we're not leaving it out. Our plan there is to support the existing Win32/Win MIDI API talking to MIDI devices with a MIDI 1.0 level of feature compatibility. This is for compatibility with existing apps. For new apps, that we recommend that you use the new Microsoft Windows MIDI services to access those MIDI devices. As I mentioned, the API is an extension to our existing WinRT MIDI, but without the limitations which hampered adoption there. For example, we're not requiring asynchronous methods so that you can manage threading and synchronization in your own apps. We have more information captured in the API as well, so the user can gain more visibility into and control over what is using MIDI and how it's using it. We're also making sure that developers have access to the raw data for messages that don't need to be handled by the OS. And then we provide helper classes to build strongly typed MIDI 1.0 and MIDI 2.0 UMP messages, but those are optional. We don't require their use. This is especially important for developers who want to prototype new message types. The ability to easily prototype new messages and new transports is a key part of the design goal for Windows MIDI services. There's also a lot to MIDI 2.0 that wasn't there in MIDI 1.0. There are new concepts as well, and the topology can be more complex. The standards typically describe a how and a what at a protocol level, but deliberately don't cover how this information would be presented to developers, to applications, and to the operating system. To help ensure that your app development experience is consistent across platforms, the MIDI Association has a working group with representation from Apple and Google and Linux and Microsoft, plus several individuals involved in the spec creation and creation of several important apps and devices. We're meeting weekly right now to get better synchronized with these concepts. We're not trying to make the APIs exactly the same across all the different operating systems. We all have different features that we want to implement as well as different compatibility requirements. But we do want to ensure that if you see a concept like an endpoint on one operating system, that when you see it on another operating system, it's going to be conceptually similar and therefore easy to learn how to code for MIDI 2.0 in a cross-platform way. Let me touch on a highly related and important topic here. ARM is very important to the Windows ecosystem. We have consumer Surface touchscreen devices running Windows 11 on ARM, and now we have a developer-ready desktop kit. I have several ARM devices here. This is the desktop development kit. This is a Surface Pro X tablet. And I use the Surface Pro X when I'm outside doing polar alignment and for my telescope. And the dev kit is for some personal projects here. One requirement we have for the new MIDI API and drivers is that everything equally supports 64-bit Intel architecture as well as ARM64, and in the case of non-kernel code, ARM64 EC. Intel architecture x64 apps, as is, are JIT compiled to ARM64 native code and will, in most cases, run just fine on ARM64 devices. But they aren't able to take advantage of features like the neural processing unit for machine learning inference or the battery savings that's provided by ARM64 or some of the other performance enhancements. ARM64 compiled apps will have access to all those things, but they cannot interop with Intel x64 code in the same process. So considering that most plugins and ASIO drivers today are user mode Intel x64 code, this is a limitation for you. So we introduced ARM64 EC, which helps by providing a native ARM64 instruction set, not emulated, but using Intel x64 compatible registers and calling conventions. It's emulation compatible. That's what the EC stands for. If you compile an app to ARM64 EC, it can load Intel x64 VSTs, or if user mode, the existing x64 ASIO drivers. It maximizes backwards compatibility while allowing you to take advantage of platform features. This is super important for us, especially in the music industry. I have a blog post which covers how to apply these concepts to VSTs in particular, and I'll share a link to that in the chat here. So for your apps, in addition to Intel x64, we recommend compiling to ARM64 EC if you have any Intel architecture dependencies like existing plugins, or straight up ARM64 if you don't. If you are a plugin developer, to maximize your compatibility and performance, we want to support Intel x64, ARM64, and ARM64 EC, and that will cover the gamut of all possible architectures that you're going to be working with. If you're creating any kernel mode drivers, we ask you compile to both ARM64 and Intel x64. Emulation is not available in kernel mode, so ARM64 EC isn't needed or supported there. So now that I've introduced the project, we'll talk more about the API and tools in blog posts throughout the coming months, including an announcement when the repo is open to the public and we are available for participation from the broader community. So thank you so much for your time today. I'm actually really excited about this project and the apps that will use it. So if you're developing an app that targets Windows and is a music industry application and you want to talk about music creation, MIDI 2.0, ARM64, or using the MPU for machine learning models, please contact me at pete.brown@microsoft.com or through any of the other mechanisms here. Thank you. And with that, I'll turn it over to the rest of the session.
Hi, I'm from Google. Along with talking with me will be Phil Burk, my colleague. And today we're going to talk about MIDI 2.0 for Android. We're going to talk about the USB transport as well as app-to-app negotiation. Phil has been working on MIDI 2.0 for a long time. In 2007, he joined the MIDI 2.0 working group. And in 2015, he started working on API. I'm Robert. I joined Google a year and a half ago, and I developed the new Java USB transport for MIDI. And this will now support MIDI 2.0. So this is what MIDI looks like on Android. As Pete mentioned earlier for Windows, we have something quite similar. We have our app talking to some manager, MIDI to the MIDI service. Once you talk to the MIDI service, you can see different types of devices. You can get virtual devices, you can get Bluetooth devices, or you can get USB devices. Do is call get devices. For our design goals in terms of MIDI 2.0, we want to support more devices. We want to make it easier for OEMs to use it. We want to have a simple developer experience, and we want to have a fast way of bug fixes. And in terms of MIDI 2.0, what changed? Our API for sending and receiving data has always been really simple. Phil can touch more about that later. We have a new way to discover UMP devices. It's just get devices, but now we can say get device for transport. So now you can say, hey, it's either a byte stream or a UMP transport. And we're adding a bunch of libraries on GitHub. Changing stuff in OS is not as easy as putting libraries above on GitHub, and it makes it so there's faster iteration. And with that, Phil will talk more about MIDI 2.0 legacy Android.
Thanks, Robert. So I'm going to talk about how apps can use MIDI 2.0 even on old versions of the operating system. Just a quick recap. The data structure is different between MIDI 1.0 messages and MIDI 2 messages. With MIDI 1.0 messages, there were a byte stream, and the beginning of a message was indicated with a high bit on the. In the universal MIDI packet, it's some number of 32-bit words, and there's no bit that indicates that this is the start of a packet. So if they're in a part of a byte stream, you have to know who you are and do your own, maintain the proper framing. So it turns out that that will work with the existing Android MIDI APIs for sending and receiving. Android MIDI API was developed in 2015. We were already working on MIDI 2.0, and we knew basically what the package would look like and what we had to do. So it was designed at that point to be compatible with MIDI 2.0. And so to improve compatibility, basically, we just sort of ignored what's in the packets and didn't really rely on any the content of the MIDI 1.0 messages. So the Android MIDI API the messages through most of the service. So then another key element is that since UMP is packet-based, you have to be able to send a discrete block of and have that preserved as a packet as it moves through the system. And so that's already a part of the Android MIDI API. When you send a block of bytes, this could be MIDI, or these could be UMP messages stored in a byte array. You just send block of bytes, an offset number of bytes, and that moves as a unit through the system. So when the receiver gets that, it knows that that's the beginning of a packet. So this is sort of shows what different parts of the stack have what knowledge they have of MIDI. So at the application level, obviously you have to know how to parse and encode messages, and also there are support libraries that will help with that. In the middle, it doesn't know anything about the protocol, but it does have this device discovery, and Robert's going to talk more about the changes in the device discovery. At the USB and the BLE transport level, it does have to know about some aspects of the actual MIDI messages. So so BLE, for example, is split. So that there is some requirement for knowledge there. But if an app is an Android MIDI, one app can send MIDI to another app. So you might have one app, general MIDI synthesizer, and then some other app can just open up the synth on that app and then send it MIDI and use that as its general MIDI synth. So when two apps start talking together, they initially by default 1.0. But if you just suddenly start sending UMP messages and the other app isn't expecting it, it'll be thinking it's getting MIDI 1.0. So we negotiate from MIDI 1.0 using sysx. Can you take MIDI UMP packets? Yes, I can. Okay, let's boom, and then they can switch to the UMP packets. I just sort of learned this weekend that the protocol negotiation was deprecated. So we either will be providing a Google proprietary sysx for that, or I think Mike mentioned there may be an alternative negotiation. Okay, well, I'll talk to Mike after. So we'll put that in the support library. So two apps can just say, you're an app, do you speak MIDI 1.0? And if it doesn't respond, then you just stay at the, or do you speak MIDI UMP, and if it doesn't respond, just stick with the MIDI 1.0. So we're focusing on putting libraries on GitHub so that they can be run back on old versions of Android. In Android, there tends to be often a lot of phones which are 2, 3, 4 behind the current version. And so it's important that apps run on that in order to take advantage of the larger market. So we're writing this code in Kotlin, and it'll handle things like packet encoding, decoding, and make some of the capabilities inquiry a little simpler, because that's a lot of sysx, which can be a bit tricky. So I want to turn it over to Robert again to talk about the transports. USB. Thanks.
Android T was the last release of Android. Came out a couple months ago, and today, if you do have an Android phone, you can try MIDI 2, assuming that you have a, which are quite hard to get right now. So we all saw this diagram earlier. Why are we seeing the same diagram? Because this is going to be the changes we made in Android T. The app, you say get devices. Now we're going to call those legacy apps, because for MIDI 2, we'll have a new type of app, and you say, instead of get devices, we'll say get devices for type. Have these different transports. I guess it should be get device or transport, probably typo here. Yeah, but so earlier, so like in USB service, because right now we only support USB. Instead of using some also MIDI devices, we'll have legacy MIDI devices and UMP MIDI devices. We'll separate the two types of devices, one for the old stuff and one for the new stuff. Your legacy apps will talk to the legacy devices, and your MIDI 2 devices apps will talk to the UMP devices. So Android S was the version before, came out a little over a year ago. It's where one app talks to ALSA. And in Android T, we made it so your MIDI 1.0 apps will now talk to our Java USB MIDI, and our MIDI 2 apps will talk to USB MIDI, but in universal MIDI packet form. How is this possible? This is part of the spec for MIDI 2.0 on USB. All these keyboards, they have two interfaces. One interface with alternate setting 0, and one interface with alternate setting 1. Alternate setting 0 will have all the stuff that was there before 2.0, and alternate setting 1 will have all of the new stuff. So we can simply open up alternate setting 0 for old apps, and alternate setting 1 for new apps. This will ensure backwards compatibility. And we wanted to make the API as simple as possible. So the changes is within 3 slides. We introduced 2 variables, transfer MIDI bytes, and transfer universal MIDI packets. Your old apps can now use transfer MIDI byte stream, and your new apps will use transfer universal MIDI packets. It's just a type of packet. And instead of calling get devices, we could say get device for transport. We deprecated get devices because it's a little confusing once you have the 2 types of transports. So you just call get device or transport for either old stuff. But even if you use get devices, they'll work for now. We might take it out maybe a couple of years, but they'll be supported for a while. We'll just mark them as deprecated. And then to dynamically get devices, right? Let's say I have a phone. I want, like once I plug in a keyboard, I want to pop up. We have a callback. It's called registered device callback. This existed for a long time, 2015. But now instead of saying, hey, get the registered device callback, you have a new parameter called transport. And this says, hey, give us all the old devices, the byte stream devices, or give us the new devices, universal MIDI packet devices. There's also one other change here, which is, if you're careful, it's some handler with executor. This doesn't really matter. It just means that we're, instead of having a handler with one thread, now you can have like multiple handlers, like multiple threads. We have some samples out you can try today. .com/Android/MIDI samples. One is the keyboard, one is the scope. If you actually have a MIDI 2 keyboard, you can go try it out. And with that, we're going to Phil, and he'll talk about the Ethernet transport.
Okay. This will be brief. One thing that we're very excited about is development that's going on in the MMA Ethernet transports. I'm not going to go into any details, but I think just the fact that we're talking about it is known. And it's there have been other earlier transports like RTP MIDI, but we're looking at a sort of a big update for that. The idea is basically you can just connect everything in your studio with Ethernet, and as you know, there are audio over Ethernet. There'll be MIDI over Ethernet, and you get power over Ethernet, so you can just have one cable connecting everything. This gives you can do software routing, reconnecting without having to run around plug-in cables. One thing I really like about, I like things to be as high up in the stack as possible. You can implement an Ethernet transport without any changes. It's just using sockets, and so an app can do this, and it'll run on any version of Android that has support for Ethernet, which is way back. An example of a kind of Ethernet app would be a legacy app that's talking to the Android MIDI API, which talks to another app that's a proxy, and it could bridge between the Android MIDI apps through the Ethernet, and that would allow a legacy app that doesn't know anything about Ethernet with apps across the network. So that's pretty much it. I want to turn over now to Torrey, and thanks for listening.
All right, thanks everyone for sticking around. My name's Torrey. I work for Apple on the Core Audio Frameworks team, and I'm here today to give you a brief talk on MIDI 2.0 on macOS and iOS. So first, here's the agenda for today's short talk. I'm going to say MIDI 2.0 a lot today, but please hear that as MIDI 2.0 and Universal MIDI Packet, because everything that I talk about today not only applies to MIDI 2.0, but also applies to MIDI 1.0 in Universal MIDI Packet format, MIDI 1-up. So the talk's going to begin with the Universal MIDI data packet structures that are used throughout all of Apple's frameworks that support MIDI 2.0. We're going to go on to Core MIDI's Universal MIDI Packet APIs, USB MIDI 2.0 capabilities from there, then Audio Unit APIs, AV Audio Engine APIs, and we will finish up with talking about some Pro App support. All right, MIDI 2.0 is descending on the music industry. And with support built into Core MIDI, Audio Unit V2 and V3, AV Audio Engine, there's never been a better time to make your software projects MIDI 2.0 native and or compliant. Now, this is a high-level talk. I'm not going to be showing you any code here today, but I will be talking about APIs. You can find very detailed information about all of these APIs on Apple's worldwide developer website, developer.apple.com. I'd like to basically point out how simple it's going to be to make the jump to MIDI 2.0 in Apple's frameworks if you haven't done so already. And without further ado, we will begin with the Universal MIDI Packet data structure. MIDI Event Packet and MIDI Event List are used throughout all of the frameworks at Apple that support MIDI 2.0. A MIDI Event Packet is a variable length structure that contains a UMP stream, simultaneous events that happen at the time indicated by the timestamp field of the length in the word count fields, the number of 32-bit words in that UMP stream, and then a pointer to those actual words. These packets can be put into a larger variable length structure called the MIDI event list, which has a field for the protocol, whether it's MIDI 2.0 or MIDI 1-up, the number of packets in the event list, and a pointer to the can always iterate to the subsequent packets in the event list by using the MIDI Event Packet Next API. So these are the Core MIDI legacy APIs. If you've used Core MIDI before, these APIs are all familiar. MIDI Send and MIDI Receive use the legacy data packet structures, MIDI packet and MIDI packet list. And then we've also got here MIDI input port create, destination create, source create. All of these legacy APIs now have UMP, and those are going to use MIDI event lists. So MIDI send event list, MIDI received event list. And then also for the MIDI input ports, destinations, and sources, you can now create those and choose the protocol at the time of creation. So Core MIDI handles all of the I/O on the system in MIDI 2.0 natively, and if necessary, will convert to the receiver's protocol on delivery. That means that anything that you would already do, you can now do those same things in MIDI 2.0 and still communicate to MIDI 1.0 listeners in their native protocol using automatic translation. All right, you'll find all those APIs that I just mentioned this .h file alongside their MIDI 1.0 API counterparts, which have all now been deprecated, but of course not removed. MIDI 1.0 is not going anywhere, as well as some useful helper APIs. And in MIDI H, you'll find a variety of convenience functions for constructing your own UMP messages and handling MIDI 2.0 and MIDI 1UP. So if you're not familiar with the MIDI, if you're not familiar with the universal MIDI packet format, you can just use our to help you create those messages. Next, on to USB MIDI 2.0 support at the OS level. The USB MIDI 2.0 spec was ratified by the USBIF a few years ago, and there's currently a large effort underway for USB MIDI 2.0 hardware in the MIDI Association. You'll be glad to know that we've got support built right into macOS and iOS when those new products ultimately reach the market. And I also want to be clear here that I'm OSs. Everything that I'm talking about today you can find in macOS Ventura or iOS 16. You don't need to wait. So if you have an alternate setting for USB MIDI 2.0 and you require MIDI CI to determine the protocol of your endpoints, Core MIDI's USB driver is always going to negotiate to MIDI 2.0 if it's available. We don't currently support jitter reduction timestamps, but if you are interested in prototyping a solution that requires them, please get in contact with how in the next slide, okay? So the group number is also going to be translated if necessary. If you are dealing with MIDI 1.0 and it's been up-converted to universal MIDI packet, then it is being sent to a destination MIDI 2.0 device that, say, only receives information on group 3, and Core MIDI is going to translate all of those messages to group 3 for you so that they get delivered to the correct place. If you USB MIDI 2.0 class-compliant hardware or USB MIDI 2.0 firmware for existing devices, please send us your prototypes. The correct way to get in touch with us about that is to contact Craig Linson, our partnership manager, him in the audience today, but his email address is very memorable, craig@apple.com. And if you need to get in contact with me, Craig can put you in contact with me directly. Let's move on and switch to the audio unit APIs, which also enjoy MIDI 2.0 support on macOS and iOS. Both version 2 and version 3 of audio units support MIDI 2.0. For more detailed information on the implementation, you can look at the indicated URL here on Apple's GitHub. And for version 3, there's actually an Xcode template for constructing these audio unit version 3, also known as audio unit extensions. And also, very long, but hopefully memorable URL with some more information there that I'll give you a moment to copy if you choose to do so. The extra short version here is properties that control MIDI 2.0. These are the properties that control MIDI 2.0 for all audio units, host side and audio unit side. Like Core MIDI, the protocol is going to be converted anywhere it needs to be for legacy audio units or Next, let's move on to AV Audio Engine APIs. You'll be glad to know that MIDI 2.0 support is there as well. And if you've already been using AV Audio Engine, you'll see that this is, that change 2.0 natively is as simple as you've come to expect so far. For your MIDI instrument AUs, the AU MIDI output block now has a UMP counterpart called AU MIDI event list. And that event block can be used by MIDI processors in the Connect MIDI API, now expanded to support UMP. Again, if you only understand MIDI 1.0, that is what you will get, even if the far end is using the new MIDI 2.0 API 2.0 natively. All translatable messages will be translated upon delivery, if necessary, automatically. Bless you. All right, let's move on to talking about Pro apps. In addition to our MIDI 2.0, across the board, Logic Pro also supports MIDI 2.0 natively. Whatever you did with MIDI 1.0 messages in Logic, you can now do with the MIDI 2.0 equivalents, and Logic will also process the MIDI 2.0 channel voice attribute data and use the new combined program change format in Universal MIDI Packet. So MIDI 2.0 supports native at the I/O level and for AUs for all existing MIDI features in Logic. Is to make sure that the MIDI 2.0 box is ticked in the project settings, and just like that, you're using UMP. Okay, to recap, today we talked about event packets and event lists, the building blocks around which audio unit and AV audio engine MIDI 2.0 APIs are built. We also talked about USB MIDI 2.0 support on macOS and iOS. And I finished up with telling you can use MIDI 2.0 natively, even with. If you don't remember anything else that I said today, please remember this. If you're already on Apple's platforms using our APIs, moving to MIDI 2.0 is simple. And if you're not on our platforms, check us out. These are powerful APIs that you can use not only to maintain compatibility with existing MIDI 1.0 technologies, but you can also prepare your technology solution for the future. Okay. Help us continue to deliver high-quality MIDI 2.0 APIs by alerting us to any bugs that you find using Apple's Feedback Assistant website. That's feedbackassistant.apple.com. Now, what if you're not seeing as a bug because you're new to UMP? That's okay. Same point of entry, feedbackassistant.apple.com. What if it's not a bug, it's a feature, something new that you want to see with MIDI 2.0? Same website, feedbackassistant.apple.com. Also, please don't assume that Apple knows about an issue so that you don't need to file a feedback report. First of all, we might not. And even when we do, we can better the impact of the problem on customers or developers or the industry with multiple unique reports from multiple sources. Now, these multiple reports are going to add visibility to an issue and to add urgency. Once again, that website is feedbackassistant.apple.com. Hey, you're paying attention. I really appreciate that. Okay, thanks for your attention today. That's all I have.